So research has shown that most engineers who work with data spend a lot of time writing sophisticated SQL code. But over the years, we are all aware large language models have now evolved in a way that they can write a pretty much decent SQL code. That's why in this tutorial, I'll be teaching you how to build a simple Streamlit based app that takes your database configuration and in plain English text, it can generate you a SQL code. So all you do is to describe how your database joins look like, and then you can write a simple English, and this particular app will generate you a SQL code that you can run and retrieve the data. No more thinking about how to write sophisticated SQL code. All you need now is to just describe what you want and copy the SQL code and retrieve the data. We'll be using tools such as LangChain, OpenAI, and Python. And all the code in this particular tutorial is on my GitHub repository. Link will be in the video description. So you can just click on it and have access to the code base. If you think there is something we need to add to this particular code, just make a pull request and you can add that, or you can even leave a comment there for me and I can add that for you. Right after watching this video, you gain knowledge on how to use large language models to generate SQL code. Alright guys, so starting off, I'll be using Visual Studio Code as my code editor, and also I'll be using UV as my package manager as well. You guys can go ahead and use any code editor of your choice, and you can also use any package manager of your choice. I know most of you are very conversant with pip. You can go ahead and use pip, but I'll be using UV because it's extremely fast when you are trying to install libraries. So what I'll do here is to type UV init, and this will just initialize some files, some project structure in my directory. So it gives me main.py file, also readme pyproject.taml, which will hold our dependencies and so on. So up next, let me clear my terminal and then go ahead and install the libraries we need. So we need LangChain, and all you have to do is to do UV add and the name of the library. So LangChain. We also need LangChain OpenAI. You can type all the libraries on one line and it will install all of them. So this should be LangChain OpenAI. Another library we will need for managing our API keys and stuff will be Pydantic settings, right? So just type that in, Pydantic settings, and finally we'll need Streamlit. Okay, so these are all the libraries we need. If we need any further libraries, we'll just go ahead and install them. So I'll hit enter on this, and you can see how fast UV will add all these libraries. So just done, and that's UV for you. So we are just done installing all these packages I've typed in. If you try the same thing with pip, I think it's going to take a lot of time, but if you are conversant with pip, just go ahead and use it. So yeah, that's it. The next thing I'll do is to create some folders. Okay, so let's create a project structure, and what I'll do is to create a first folder here, which I'll call config, right? So just to hold our configuration, so let me call it configs, right? I'll create another folder, and this folder I'm going to call it prompt. So this will hold our prompt, the prompt that will guide the LLM on the output we want. So I'll call this prompt, and that's it. So these are the two folders we need for now. If we need any other thing, we'll just go ahead and create them. I will create another file as well, which is called .env. So I'll call this file .env and hit enter, and inside this .env file you need to paste your API key. So you have to paste your API keys and the model you want to use. So I'll go ahead and do that. The model I'll be using is from OpenAI, so I have to just type OpenAI underscore API underscore key, and this is equal to my API key. So make sure you create an OpenAI account and get your API key and paste it right here. Also, I'll specify the model I'll be using. So my model is equal to, and this I'll be using GPT 4.1. Okay, you guys can use any model of your choice, but I'm going to be using the GPT 4.1 model. So yeah, this is the model I'll be using. Guys, just make sure you use the same kind of model in order to get the output I'll be getting. But you can use any model. You can try different models to see how best it will output the SQL for you. So I'll be pasting my API key here. I don't want you guys to see it, so make sure you just write the same variable name and paste your API key. That's all for you, but I don't want you guys to see my API key, right? So I've pasted my API key and closed the .env file. Now we have to go into the config folder, and inside this config folder I'll create one file called config. So let me just call it config.py. And inside this config.py, we'll load our API key, and we'll be using Pydantic settings to do that. So all we'll do is to write from Pydantic setting, we are coming to import base settings. Okay, so yeah, base settings, and I'll just come here, create a class, and this class I'll call it settings, and inside here it will inherit the base settings class, right? And after this, all you need to do is to define your variable names. Make sure the variable names are the same as the ones in the .env file. So in the .env file I have openai underscore API underscore key, and that the data type for that is a string, so I'm just going to type str here. I also have model here, and the data type for that model is also str, which is a string. Okay, so these are all the environmental variables I have, openai key and the model, which are all strings. So I'll create a class here to tell this particular file where to locate my env file. So class, and I'll call this class config, and here I'll say env underscore file, and this should give the path to my env file, which is in the same directory .env. So yeah, that's the name .env, if I can spell env correctly. Yeah, so this is it. You can also specify the encoding and all those stuff. So you can do env underscore file underscore encoding, and then you can type the type of encoding you are using, but the number one to type will be UTF-8. So UTF-8. And the last thing, if you want to ensure maybe for it to be case sensitive or not, you can also write that. So case underscore sensitive will be equal to true, right? So yeah, that's all you need to do in this file. And finally, we can call this settings, and this settings is equal to our setting class, and that's it. So now we can call this setting to get the API key and also get the model. For instance, you can just do settings dot model, and you will get it, settings dot open AI API key, and you will get it. So that's what we'll be using to get both our API key and the model as well. And that's all for this particular config file. All right, so I'll create another folder called model, and inside that folder I'll set up my LLM. So let me just go ahead and create that folder. Let me call this folder model, and inside this folder I'll create a file, new file, and call this file llm underscore setup.py. Okay, so yeah, this is where we'll be setting up our LLM, and in this file I'm going to go ahead and make some couple of imports. So the first thing I'll import is from LangChain. So from LangChain.chat models, I'm coming to import the init chat model. And also, to get our API keys for this init chat model, we need to import that from our config file, right? So we take from configs, and inside the config folder we have a file called config. We are coming to import our settings, and we'll be using that to initialize our model. Okay, so to set up our model, we have a variable here called model, and model here will be equal to init. Okay, we are coming to instantiate the class we have imported from LangChain init chat model, and inside this init chat model it will take our API key and our model, and we have done that already, which we can get from settings. So settings can give us both the API key and our model. So what I'll type here is to type API underscore key. We are getting that from settings, which we are imported dot OpenAI API key. That's simple. And the next one is our model, which is also equal to the same settings dot model. So this will give us both the API key and the model. And to test if our model is working, we can just print something here and say our model dot invoke, and inside here let's just put some hello so that it will give us some other response. Yeah, so let me save this and let me run this file and see if the model works right. Okay, so we have some import error. They said from configs.config import setting and no module named configs. Wow, let me see. No module name configs. So let's see, from configs is the name of the folder, config.py is a py file, and we want to import, how do we call it, settings from it. So I don't know why it's saying it can't find that particular file, but let me see. This is a common problem with Python, so let's try to create a file here, and let's call this file __init __.py, and click enter to see if it will treat that as a module. So I'll come back here, save this, and try to run again to see if I'll encounter the same error, and I've encountered the same error. So with even the init file is not working, so what I'll do here is to maybe import system and OS and make sure it sees the model folder as part of the directory. So I'll import sys, which stands for system, and also import OS. Finally, I'll just have this here that tells it see LLM setup as part of the module path. So let me save this and try to run it again, and let's see if it works. So let's see if the LLM works, and yeah, here we go. So hello, how can I assist you? So guys, our LLM setup works and it's looking good, right? So yeah, our model is working. The next thing we have to do is to have a function that will take a prompt and then return SQL. So the function will take the prompt, and the prompt you are yet to do, but that prompt will guide on the LLM on what to do. But before that, let me teach you guys something here. We'll actually be using model.stream instead of model.invoke. And with model.stream, what we'll get is that it will be producing the output in a sequential order. Let me show you a quick example. So let's say our result is equal to model.stream instead of model.invoke. And here we can say, okay, tell me a story about AI. Okay, so something like this, and whatever this model will return will be a generator. With model.stream, it returns a generator, not the actual text. So we can just loop through the result for data in, let's say, result, and here what we can do is to print our data, right? Print our data. So this data, we want the content out of it. We don't want all the other things that comes with the OpenAI. So we just want the content. So we just say content, and this will give us the content from whatever story the model is going to tell us. So let's try this, and I just want you guys to get this before we implement it into our Streamlit interface. Okay, so you can see it's telling us the story, but the formatting looks a little bit weird, which I don't like. So what I'll do here is to change the end in the print function. So end, I want end to be an empty space, and also I'll specify flush here to be true, which tells the print function that okay, whatever data you have, just flash it out, don't buffer a lot of data before printing it. Okay, so yeah, that's how the flash work. And now if I should give this a run, we should see the text appearing one after the other where it's telling us the story. So yeah, we want something like this, not that we just use the invoke to get all the tests at once. So this works and this looks good. You can see how we are getting the story line by line. We don't wait for it to buffer everything. Let me clear this, and that's the particular implementation we'll be using. So I'll comment this now and continue with the function. So with the function, we'll call this function LLM. So let's define a function called LLM, and LLM will take a prompt, and all LLM will return is to use that prompt in order to tell the model that okay, return this particular SQL for me based on the prompt. So what I'll do here is to first try, and I'll take this into response, and this will be equal to our model dot stream, right? And inside here we'll give it a prompt. So we are trying this to see if we get response. If we don't get it, then we can put an exception block here. So accept exception as E, and if there is exception, we can print an error message saying okay, we encountered some error fetching the data, right? And inside here we can put the particular error here. Yeah, so this is what we'll be using, and this is the function we'll be using. So when you give this function any prompt, based on that prompt it will return as some output, and we can test the function. So we can just call LLM, and inside LLM here we'll give it a prompt. So let's give it an example prompt which is equal to tell me a short story. So this is just by testing the model, and we'll assign this to results because it will be a generator, and then we can even use what we have here to print that particular story. So let's test the function and make sure it works before we import it and use it in our main.py file. Okay, so we got some error. Results, we have result is LLM. It takes prompt, tell me a story. What's the error we are getting for data and result? We have LLM here. Prompt is tell me a story. Oh, okay, so yeah, over here we should return that particular thing. So we are getting none because we are returning nothing from our function. So I'll just return response. Yeah, that should be it. This should fix our error for us, and let's give it a try again. Yeah, so you can see our story being streamed on our terminal, which looks good. So our function works and everything is working. I'll clear this, close the terminal, and what I'll do is to get rid of this whole thing here. Yeah, so this is our function. It tries to get our result using the prompt, and then when it doesn't get it, it returns some error. When it gets it, it returns our response. So this is the function that we'll use to generate the SQL. All right, so now let's go ahead and create the prompt. So in the prompt folder here, what I'll do is to create a new file, and I'll call this file prompt.py. And inside prompt.py, we are coming to create a prompt that will guide the LLM on the output we want. So we have to from langchain dot underscore core, that should be core dot prompts, right? We want to import prompt template. All right, so this prompt template, we'll use it to create a prompt. So let's call our prompt SQL prompt, and our SQL prompt is equal to prompt templates. So inside here, we'll give this prompt template some input variables. To generate the SQL, we need a database name, whether there is some relationship between the tables, the particular SQL you want to generate, which I call it action. So we'll put those things in the input variables, not input type, input variables, and we'll make this a list, and inside this list it will have whatever we want. This is going to be lengthy, so I've written this down. So all I will do is to copy this and paste here and explain it to you guys. So I already have this prompt somewhere here. So let me paste the whole thing here, and then I'll take you guys through it. All right, so this is the prompt. As usual, we are importing from langchain core prompt template, which I've done this, and the input variables, this here it is. We have the table name, the column, the database, relationship, and action. So the table name will be the name of the table you are using, your database table. The columns are the columns in the database table you want to retrieve data from, and then we have the database name, which we have to also provide. So here we are telling our prompt template, okay, this is our input variables, and this is the template we'll be using. So we are telling you an expert SQL generator for a company called TechWatt, which is my company name or YouTube name or something like that. Given the following information, I can put this here. Following information, generate SQL query for the action. So the action is the particular query you want, and you see that in the interface. And then we give it the table name, the columns. So here I just have a further explanation for the LLM to get what these columns means. So a list of columns, it can be a list of columns. So let's say for a table called users, we can have the name of the users, the age, their height and weight, and so on. And the table name as well, the name of the database tables. You can have double tables if you want to perform some joins. Okay, so yeah, this is the prompt. You can just go through it, and it's very simple. This is a prompt we'll be using to retrieve data. Okay, so yeah, that's just it. So now I think we are done with our prompt. We are done with our model setup. I think this initpy, we don't need it because it's not working, so I can go ahead and move it to the recycle bin. We're done with the model, we're done with the configuration. So the main thing now is to go into our main.py file here, get rid of this code generated by UV, and we'll do some imports. Okay, so first of all, from our config, that should be configs.config. Do we need anything there? Let me look at whatever we have here. Do we need anything from config? We don't need anything from config. So yeah, I don't think we need anything from config. So let me import Streamlit as st, and also from model.llm setup, we import LLM. Yeah, so we'll need the LLM to take our prompt and also generate something for us. From our prompt we'll import the SQL prompt as well, and this is the prompt we'll be using to actually generate SQL. So yeah, we have this particular imports, and I think this is all we need. Now let's go ahead and create the Streamlit interface. So first of all, we need a title, and it's just easy, st.title. And inside this title we can tell it, okay, we are doing text to SQL generation, which I have some of these things written down here, so I'll just kind of paste them in and explain for you guys. My intention is not to make this tutorial too long. So st.title text to SQL generator, and then we have a markdown which tell our users this is the things you need to do in order to get SQL test. So it's a markdown, st.markdown. Streamlit is very easy to use, so easily generate SQL queries by providing simple detail about the database table. Yeah, so this is information for our users. All right, now that we have this, I think the right thing to do, we can also run this particular code in order to be seeing whatever we are designing on the go. So let me run this, and yeah, to run a Streamlit app you need to type this particular command, Streamlit run, and the name of your file. So let's type that, Streamlit run. The name of my file is main.py. So let me quickly run this and let's see if it works. So yeah, it will open the browser for you, and see, this is what we have designed so far. So text to SQL generator. All right, so let's go ahead and create a form now. I'll just lower this in the background, and let's create a form, and this form will take the input from the user, and on submission we'll call the LLM to do that particular action for us. So form creation is very easy. We just do with st.form, and then we give it some text. So with st.form we are coming to create SQL generator form. We give a subheader called input details, which tells the users to input the particular details we want. So always rerun, and we have input details. We are having some errors because we are not done with the form. All right, so from here I want to be a little bit creative, so I will design two columns for this particular one. So I will just have column 1, column 2, which is called 2 is equal to st dot columns, and inside here I'll put in 2 here, which specifies that okay, I need 2 columns, and these 2 columns will take the database name and also the table name. Okay, we'll use these columns to tell the users to input the database name and the table name. So I'll paste that here. So with column 1, which we are working with column 1, we want to take the database name, which is sc.test input. This tell the user the database name, placeholder example customer this b. So we are just a simple design here. Let me see what that looks like. So you can see we have database column here and also a table name column here. Let's go ahead and finish it for the rest of the columns. So all this code will be on the GitHub repo, well documented and explained, so you guys can just see it. So we have additional columns here, so these ones are not even columns, just have some text inputs. This is also a text area so that we can make it a little bit big, and also the action we want to perform. So when I save this now, I'll go back, and now you can see we have this particular template. So this is just a form to collect the data from our user in order to generate the SQL query for them. All right, so yeah, with that, now let's create a button, right? Let's create a button to submit this form, which I'll quickly put here. So submit form is st.form submit button, and this button will tell them to generate the SQL query. But before we generate this query, let's make sure we validate the inputs. Okay, so if a user didn't type anything and try to generate query, let's refuse that. Okay, so what we'll do is write an if statement here and say if submitted. If submitted is the case, then let's check if the user have inputted everything. So I'll create a variable here called data, and data will be equal to a list, and inside here I'll put all the names of my columns or my fields in that particular list. So if we have database name, we'll have action, we'll have columns. So these are 3. Which one is left? We'll have table name as well. table name. Okay, so we'll have table name. For the relationship, I'm not going to put it there because it's optional. Some people have only a single database with no relationship, so I don't want to ensure that they put relationship all the time. So yeah, so we'll have this, and what we'll do is that we'll check if not or, and we'll put in the data here. So what this is actually going to do is that to check if all these variables have some data associated to them before we go ahead and submit. So if not all, then we have to stop the people. We have to do st.warning. Let's put a warning here telling the people that they need to make sure all these input fields are provided or are filled before they press the submit button. So yeah, in the st.warning, I'll just paste in this text here. So st.warning, and I'll put this warning here. Let me get rid of one of these and one of these as well. So please fill in all the field before generating SQL, and we'll make sure we hold on there. So we'll do st.stop, and we'll stop and be waiting for the user to fill all those fields. Okay, so we'll just check this and make sure all the data is being validated, all the input fields are being filled before we proceed. So if everything looks good and the user have provided all those fields, then we can now go ahead and generate the SQL for them. So we'll use some spinner effect here. So st.spinner, and that should be with st.spinner, right? If I can write. And inside here we'll put some text called generating SQL, right? So we'll have this, and from this now we are coming to pass all this data we have into our LLM. Okay, so what we'll do here is to call this SQL query, which stands for our query is equal to, we'll call our LLM, and inside this LLM here we'll give it our prompt. So the name of our prompt here is called SQL prompt. So we'll just put it here. We'll say SQL prompt dot format. Okay, we can format it in order to provide the various input for it. So when we format it now, we can type something like table name, and this is equal to our table name as well. We can do it for all the rest of them. Yeah, so this is all. I think it's 5 inputs. When we go to our prompt, we can see we are giving it about 5 inputs. So yeah, you should make sure you provide all the 5 inputs in order not to encounter any error. Okay, so the thing is, when we have something like tables can be sometimes like a list. Okay, so when we have a list of tables which are separated by comma, let me show you what I mean. We can have a list of tables. So let's say we have a customer table, you have a user table. We can take all of them and then we separate them by comma. So when we are receiving them here, then we have to split them. So we can just do dot split, and we are over here splitting by comma, so we'll put in comma here. Okay, so we are splitting whatever we are taking here, and we are trying to split them by comma because the user will enter them in the field splitted by comma, and we'll check if table name, else we just return an empty list. Okay, so yeah, that's what we'll be doing. We check if there's multiple table names, then when there is multiple table name, we split by comma, and we check if there is table. If there is no table, we'll do the same thing, and we can do the same thing for columns as well, because in the column we'll have name, age, so on. For, let's say for a user table, we'll have all of those things. So we'll also do columns dot split, and inside here we'll split by comma, and after splitting we can check if column else will return an empty list for the columns. For the database name, we don't need to do that. For relationship, we can do the same thing. So we can do dot split, because we can have a lot of other relationships between databases, and we are splitting by comma. We'll check if there is a relationship. So if relationship, else we'll just return none. So else, let's just make it none. If there is no relationship, then return none for the relationship field, which looks good. So yeah, this is all we'll be doing, and if all of this goes well, then we can go ahead and now display the query we'll get. Okay, so we can also check if we are actually getting query. So if there is a query, we'll go ahead and display it. So over here, I think this should be together with the width. If SQL query, if we have SQL query, then we can go ahead and display. So whatever we'll be getting, it will be a stream. And to display stream, Streamlit have a particular stream function. So we can do st.write, and over here we can write stream. So st.write stream, and we can provide our SQL query. Okay, if that is not the case, then that means we have some failure, we are not getting query. So else we can just try to print something, st.error, and inside here we can put up some error message, which I already have here. Let me just paste that here. So yeah, if that's not the case, we can just put here fail to generate SQL query, and we can also have a success message before all of this. So we can say print, if there is query, then we can say st.success or something. We can put it at the top here, st.success SQL query generated, before we continue. Okay, so yeah, let me save this and let's look at what we have here. So yeah, everything looks great, and let's test this out. So let's say now the name of my database is equal to tech what, and let's say for now, let's do it for one table name. I have a users table, so the table name is called users, and the columns I have in this particular table, let's say I have a column name names, I have age, and I have height, and finally I have, let's say, let me just have something like amount, right? So there is no relationship, like it's only one database, it's only one table, so no relationship. So what do I want to retrieve? So I can now write a plain English here: retrieve the age of all the names in my database, right, for me. And I can also continue, let's say arrange the maybe outputs in descending order, so something like this. So now I can retrieve, if I could spell retrieve correctly, descending order. Yeah, so let me execute this query and let's see how it works. Let's see, so it's running. Let's see if it will produce the output. So you can see this is the SQL output: select name age from techword.user. So this is the table, this is the database name dot users is a table in the data, order by age, descending order. So you can now copy this SQL query and use it anyhow you want. So yeah, you can see how now you can type in plain English and just get some output. Let's try one with multiple table names. So let's say we have a user table and we also have a customer table. Okay, so users and customers, and inside here, let's say we have names, age, height for the user, we have amount, and also let's say net worth of the customers, net worth, if I could spell that right. And let's specify a relationship. So the relationship, let's say users dot id is equal to customer dot id. So let's say that's our relationship. So users dot id is equal to, let's say, customers dot id. So let's say, yeah, this, they are joined with this particular id. Now let's retrieve information that will help us join maybe the two tables together. So let's say we want to retrieve the name of the user and their net worth, and this is my query. So let's try this out. Let's see how it works. So you can see we just get the SQL query: select user from name, user from this, and it performs a join on their id and limit by 5, which means give me only the first 5. So with this, we've just built a tool that you can just type plain English and then it will give you SQL to use. This will speed up your productivity if you are actually a data analyst and someone who works with databases. So guys, this is it. Let me know what you guys think, how we can improve this. The GitHub repo will be there. You can make a pull request if you want to add certain things to this particular build. Let me know what you guys think about this overall. The code will be made available, and also if you watch up to this point, make sure you leave a comment and also like, share, and let me know what you think about this particular tutorial. Okay guys, thanks for watching. I appreciate you guys so much, and I'll see you in the next tutorial.